Now we extend this idea to look at the probability of a value falling within 2 standard deviations of the mean or 3 standard deviations of the mean. Because we saw on the previous page, as long as you're interested in the probability of the variable landing on 1 standard deviation above the mean or 1 standard deviation below the mean, we can calculate that because we know there's a constant area values. 0.16 we discovered on the previous page for the right gray area there, and then 0.16 for this left gray area here, and the middle area is 0.68. But what about if we're interested in not 1 standard deviation above or below the mean, but 2 or 3? If x is a normal quantitative variable with mean and standard deviation, then the probability that x is within 1 standard deviation of the mean is approximately 0.68. Okay, we knew that from a previous page. The probability that x is within 2 standard deviation of the mean equals approximately 0.95. Okay, that's new information. Let's move down and see what else we want to see. Okay. The probability that x is within 3 standard deviations of the mean is approximately 0.997. So the previous one, 2 standard deviations, either above the mean or below the mean, would be 0.95, which is 95%. You have a 95% chance that your value, doesn't even matter what example we're talking about, you have a 95% chance of falling within 2 standard deviations of above or below the mean. So these are really small. There's not a lot of values that are more than 2 standard deviations smaller than the mean. There are not a lot of values that are 2 standard deviations above the mean. And then it gets even worse or better, I don't know. It gets even smaller when you want to know about 3 standard deviations above the mean or below the mean. 0.997, which is 99.7%. That's almost everything. Almost all the data, almost all the probability is within there. So if you are wondering, oh, what is the probability that some random value is going to be 3 standard deviations below the mean or 3 standard deviations above the mean? Not a lot, not a large value, because what's left after you take away 99.7%? It's only 0.3%. Okay, let's see then. And those are not values. These are just values that they're telling us. So now we know those. I wouldn't expect you to calculate that on your own or anything. Okay. Now what do they say? Comment. Let's take a moment to think about the empirical rule. Okay. The first statement of the empirical rule helps us to identify an interval of likely values of x. It gives us an interval within 1 standard deviation of the mean that contains the central 68% of the values. The second and third statements in the empirical rule help us identify values that are unlikely to occur. Like we said, 95% of values fall within 2 standard deviations of the mean, either above or below the mean. It is therefore unlikely for a value to fall more than 2 standard deviations away from the mean. Values more than 2 standard deviations away from the mean in a normal distribution are often called outliers. 99.7% of values fall within 3 standard deviations of the mean. It is therefore extremely unlikely for a value to fall more than 3 standard deviations away from the mean. Values more than 3 standard deviations away from the mean are often called extreme outliers. That almost sounds awesome. Extreme, like like you're going to drive a monster truck or something. Example, the empirical rule in context. It's not as exciting as driving a monster truck, but it's close. Suppose the foot length of a randomly chosen adult male is normally distributed with mean 11 and standard deviation 1.5. Then the empirical rule lets us sketch the probability distribution of x. Use this sketch to answer the following questions. Okay. I'm going to scroll down now. I got to clear these drawings and then scroll down. Okay, let's see. I'm going to try to keep the picture in there while we answer some questions. All right. What is the probability that a randomly chosen adult male will have a foot length between 8 and 14 inches? So let's look at the graph. 8 and 14, let's see, that's here to here. So notice, I think what they're saying is all these lines that they're drawing. So the middle kind of portion in here, that's 0.68. That's just 1 standard deviation above or below the mean. Yeah, that's 1. And then the next area is 2 standard deviations above the mean. I'm going to put plus just to say above. And then this left area, just to the left of the middle portion, is 2 standard deviations below. I'm going to say subtract. And this very small area on the very right represents 3 standard deviations above the mean. And the very leftmost area is 3 standard deviations below the mean. Minus. Okay. So what did they ask again? The probability that a foot length is between 8 and 14 inches, like we said, that's here to here. That means that corresponds to 2 standard deviations above the mean. And we already know that from the above, within 2 standard deviations, they just memorize it. It doesn't matter that we're talking about foot length. It doesn't even matter what these typical values are or anything. It just matters that we're within 2 standard deviations. It means 9.95 or 95%. If it was, like we said, if it was within 3, then it would be the 0.997. Why this question asks for a probability, so think area. Yeah, like we talked about. The standard deviation is 1.5 inches. 8 is 2 standard deviations below the mean. And 14 is 2 standard deviations above the mean. The empirical rule says that 95% of the time, x will fall within 2 standard deviations of the mean. Okay, so that graph really helped. If I didn't have the graph, I'd have to really think about it. Yeah, like they kind of like how they broke it down just now. 1.5 standard deviations, or is the standard deviation and all that. Okay, now here's a graph. Let's ask some questions about this one. Why is the probability that a randomly chosen adult male will have a foot length greater than 14 inches? Okay, let's see. 14, so it looks like you have to really think about, in these examples, what's the mean? So the mean here with the foot length was 11, I think. And the standard deviation we're calling sigma, it was 1.5, right? Yeah. So they say they wanted to know what's the probability that the foot length will be greater than 14 inches. I'll just say, well, compare 14 to the mean. 14 is 3 units away, I guess, which is 2 standard deviations. Equals 2 sigmas, because sigma is 1.5. So then this area here, let's see, the area that's 2 standard deviations away, we already said, from the empirical rule above, 0.95. And that would mean that what's left over after you take the middle area out is these left guys will be 1 minus 0.95. 1 minus 0.95. But that represents the left and the right. I'm only interested in values greater than 14, which means I only want this right portion. I'm going to cut that in half, whatever I get. 1 minus 0.95 is 0.05. Half of that, because I only want, yeah. If I take away the 0.95, that just represents the middle. Whatever's left, 0.05 represents the left and the right areas, but I only want half of that because I'm only interested in the right. Half of 0.05 is 0.025 or 2.5%. That's what they got here. Yeah. So they kind of describe the same thing we said. We want the area associated with x is greater than 14. Find the area of the 2 tails. That's what we found, kind of the left and the right portions, 0.05. But we want half of that, so I divide it by 2, and I'd get that tail, or whatever they said, I guess, whatever they call it. Okay, sorry if that went fast. You can always rewind it. Okay, now the last question. What are the foot measurements for adult males who are extreme outliers? Okay, remember that means extreme outlier, they said, yeah, outlier. Outliers are greater than, or yeah, 3 standard deviations away from the mean. Yeah, and we know that if you're talking about 3 standard deviations away from the mean, that the area beneath the curve in the middle, within 3 standard deviations, is 0.997. So we can do a similar calculation. It's just that now that we're within 3 standard deviations of the mean instead of 2, the middle area is different. So that means that the 2 tails will be different as well. If the middle area is 0.997, the 2 tails together would be 1 minus 0.997, which isn't a whole lot. It's 0.003. But I even want half of that because that 0.003 represents 2 parts. Yeah, so half of that, less than. Okay. Sorry, I think I misunderstood the question. I was thinking they were saying, what's the probability? They were actually asking, what are the foot measurements? So I'm sorry, let me clear all this. I was trying to make it harder than it has to be. I was answering a harder question, I think. So they said the mean, or mu, was 11 for foot measurement, and then standard deviation was 1.5. They said extreme outliers above, on the same page, extreme outliers are greater than 3 standard deviations away. So I just have to take 11 and add 3 times mu, or sorry, 3 times sigma. This represents mu plus 3 times sigma. I'll calculate that. And so that's for people that are outliers that have foot measurements way large, but what about those that are outliers that have foot measurements way small? It'll be 11 the mean mu minus 3 times the standard deviation. So I need to make these two calculations. That's mu minus 3 times sigma. 3 times 1.5 would be 4.5. 11 minus 4.5 is 6.5. So we want 6.5 is anything less than 6.5 is an extreme outlier, and anything greater than 11 plus 4.5 is 15.5. Yeah. So any measurements that are less than 6.5 and any measurements that are greater than 15.5 would be extreme outliers because they're either really tiny feet or really large feet.